Hello friends, welcome back. Let's do one more problem. We'll solve one more example related to family of straight lines, where instead of using the substitution or elimination method, we are not trying to find out the coordinates of the point of intersection. Instead of that, we are using the formula L1 plus lambda L2 equal to 0 and applying the additional condition on it and try to find out the equation of the straight line. So let's go ahead and do that. This will be the last example on this topic. Then we will move to next topic and we'll move to circles. We'll stop with straight lines. We'll come back after some time for pair of straight lines, but that will be after some time. Okay, let's move to the problem. Find the equation of the straight line through the point of intersection of the lines x minus 3y plus 1 equal to 0 and 2x plus 5y minus 9 equal to 0 and whose distance from the origin is square root of 5. This is very important. This is the condition what I have to apply. Whose distance from the origin is square root of 5. What that tells me? That tells me that if there is a straight line, let us take this straight line, and there is a point, whenever we say the distance between the line and the point, it is always perpendicular distance. We are completely aware of that. So this is the point, nothing but the point of intersection of two lines, and the equation of the straight line passing through point of this. So let us say if this is ax plus by plus c equal to 0, we have distance from origin, so this is 0 comma 0 and this distance is square root of 5. So can I say, if I substitute here c by square root of a square plus b square equal to root of 5, or c square equal to 5 into a square plus b square. So why we are going through this? Because we will now use L1 plus lambda L2 equal to 0 and we will find out the equation of the straight line which is passing through point of intersection of L1 and L2. This is L1 and this line is L2. We will find it out. We will convert that into the form of ax plus by plus c equal to 0. We are interested that we have to prove that c square equal to 5 into a square plus b square. We know that condition. Using that condition, we will be able to find out the value of lambda. Once we get the lambda, it's pretty simple. Substitute the value of lambda in L1 plus lambda L2 to get the equation of the straight line. So the major part will be to finding out the lambda. First let me go ahead and try to find out L1 plus lambda L2 how it looks like. Okay. We'll see that. So we'll have L1, that is x minus 3y plus 1 plus lambda into 2x plus 5y minus 9 equal to 0. Now I'll simplify this. X minus 3y plus 1 plus 2 lambda x plus 5 lambda y minus 9 lambda equal to 0, or if I put like terms, I will have x into 2 lambda plus 1, that will take care of both x terms. Then let's go to y terms. We will say y into, what is y term here? 5 lambda and there is minus 3. So I will have 5 lambda minus 3. Then I have 1 and I have minus 9 lambda. So can I say 1 minus 9 lambda? This is equal to 0. Now if you observe, this is in the form of ax plus by plus c equal to 0. And we have been given that the distance from the origin of this line is equal to root 5. We did already that work. The condition we have is c by root of a square plus b square is root 5, or c square equal to 5 into a square plus b square. This is where we have to find out the value of lambda. We will find out the value of lambda, then it becomes pretty easy to simplify that. C square C square is 9 lambda minus 1 whole square equal to 5 into a square plus b square. A square is 2 lambda plus 1 whole square plus b square is 5 lambda minus 3 whole square. Little bit of algebra, nothing other than that, just to find out the value of lambda. So a minus b whole square, I will expand this. I will have 81 lambda square minus 18 lambda plus a square minus 2ab plus b square, that is equal to 5 into, I will expand the 2 lambda plus 1 whole square. I will have 4 lambda square plus 4 lambda plus 1 plus 5 lambda minus 3 whole square. If I expand, I will have 25 lambda square minus 30 lambda plus 9. Now let's simplify this. I will have 81 lambda square minus 18 lambda plus 1 equal to, let me just simplify this, 4 lambda square, 25 lambda square is 29, 29 into 5 is 145. So I will have 145 lambda square, 4 lambda minus 30 lambda minus 26 into 5. I will have minus 130 lambda. I am skipping a step there, but I think you should be comfortable with that. 1 plus 9 is 10, 10 into 5 is 50. Okay. So this will give me if I get everything to the right side, I will have 64 lambda square minus 112 lambda plus 49 equal to 0. Now you can say that splitting the middle term of this seems to be a little bit difficult, but if you observe, 64 is 8 square and 49 is 7 square. So I see that it is in the form of 8 lambda minus 7 whole square equal to 0. You can see 8 square is 64, 7 square is 49, and 2ab term is 2 into 8 into 7, that is 112. So that gives me lambda equal to 7 by 8. As simple as that. See, once you got lambda, now pretty much you know what to do. We have to go back to L1 plus lambda L2 and substitute the value of lambda equal to 7 by 8. Let us do it here. Let us try to finish it here. So we will say L1, that is x minus 3y plus 1 plus 7 by 8 into 2x plus 5y minus 9 equal to 0. Okay, this is nothing but 8 into x minus 3y plus 1 plus 7 into 2x plus 5y minus 9 equal to 0. If you simplify this, you will have 8x plus 14x 22x minus 24 plus 35, that is 11y. 8 into 1 8 minus 63 is minus 55 equal to 0, which is nothing but equal to 2x plus y minus 5 equal to 0. So the equation of the straight line which is passing through the point of intersection of x minus 3y plus 1 and 2x plus 5y minus 9 and is also at a distance of root 5 from origin is 2x plus 5 minus 5 equal to 0. Just before wrapping it up, let me summarize this, what we have done here. Okay, we have been asked to find the equation of the straight line through the point of intersection of two lines and whose distance from the origin is square root of 5. So we know that whenever we see that whose distance from the origin is square root of 5 tells me that there is a line and a point involved. Whenever there is a line and point, we are talking about perpendicular distance. The formula I remember is the distance of a point from a line ax plus by plus c equal to 0 is ax plus by plus c by square root of a square plus b square. Actually I have just kept it exactly reverse here. As usual I am dumb, you have to pardon me for that. Ax plus by plus c equal to 0, and this is 0 comma 0. Always the distance from the line, from the point to the line. I have just reversed them. Okay, right. Now this tells me that the perpendicular distance from origin is x and y is 0. You will have c by root of a square plus b square is root 5. C square equal to 5 into a square plus b square. Now what we will do? We will take L1 plus lambda L2 as the equation of the line which is passing through the point of intersection. The additional condition is c square equal to 5 into a square plus b square. Apply that and find out the value of lambda. Lambda equal to 7 by 8. Now go back to L1 plus lambda L2 and substitute the value of 7 by 8. You will get that the equation of the straight line passing through the point of intersection of those two lines, x minus 3y plus 1 equal to 0 and 2x plus 5y minus 9 equal to 0, and also at a distance of root 5 from origin is 2x plus 5 minus 5 equal to 0. So I'll catch you in the next session where we'll start circles. My interesting topic. I love them. Okay, I'll catch you there in the next session. Thanks for your time. Bye for now.